So we will review within condition analysis, which means that you're only analyzing patterns within the single condition, meaning only during baseline, only during intervention, and so on. We'll look at adjacent condition analysis as well later on, but this is just within, so just within that one condition. So this is Gaston Ledford, pages 181 through 190. They give a lot of visuals to support the text. Really go through and look at those visuals. They'll be very helpful as this is visual analysis. So we'll go over a couple key terms. The first is condition length. So typically in any condition you want at least a minimum of 3 data points. However, if there's variability in that data, the condition should run longer. So if your baseline condition has scattered data, you'll want to continue baseline until you have a more stable representation of that behavior. So then we go into level. So level basically indicates the amount of variability or range in the data point values in that series. It's often described as low, medium, or high. Figures 8.1a, b, 8.2 and 8.3 have really great visuals of this. So in levels, it's exactly kind of what you'd think of that as. It's levels in the graph, so whether it's low, medium, or high, and so on. If there's low variability, it indicates that your data is stable within that level. A general rule of thumb to show stability for levels is when 80% of the data points in the condition fall within 25% of the range of the median level of all data points in the condition. So that's a little bit confusing. So you'll basically take the median level of the data points, so find that median, and then if all of the data points are within 25% of that range, that means we're pretty stable. Another key element for your within condition analysis is trend. So trend is defined as slope and direction of a data series or the direction data are moving over time. So this is described as increasing, decreasing, or remaining the same. So your trend direction would be whether the data is accelerating or decelerating or remaining flat. And then trend magnitude would be the slope of that. So how steep it is or how level it is. So we want to analyze all of those things when we look at within conditions. Variability and stability. So variability is the opposite of stability. Variability in data typically requires conditions to be extended or gathered additional data for. So as we talked about that baseline, if you have a lot of variability in your baseline, you'll want to extend that condition in order to collect more data so that we can have more stable information. Stability is predictable and provides consistent data. So that's why we want to ensure stability prior to changing conditions. If our data is not stable, it could indicate that extraneous variables are impacting our behavior rather than the independent variable alone.